Okay, now that we've seen disjunction, we'll turn to negation. And here again, there are two rules. The first rule is negation elimination, whereby we can say if not P holds, then just P holds. So double negation can be eliminated. The other rule is negation introduction. We assume the opposite of what we want to prove, derive a contradiction, and then put a negation sign on what we assumed. Like conjunction and disjunction, the elimination rules come in a pair. The first of these we're going to look at is negation elimination. This one's pretty straightforward. Suppose we're in the course of a proof and we get not P. Well, from this we're entitled to derive P by getting rid of this double negation sign using negation elimination. This is pretty straightforward and I don't think it calls for too much clarification. We discussed double negation in earlier videos, and I'll put a link to them if you want to check them out. The second and more interesting kind of negation rule is negation introduction. We're entitled to introduce a negation sign when, in the course of a proof, we're able to derive a contradiction. Here's how this works. Suppose we want to show that not P. Well, we assume P in a subproof and derive a contradiction, which we symbolize by this upside down T here, which we call the Folsom. We're going to say a little bit more about this in just a second. Once we've done this, we're entitled to introduce a negation so that we derive not P from this whole thing here. And we would cite this whole portion down here in our justification by appealing to a rule. The basic idea here is that if you assume something and it leads to a contradiction, you're allowed to infer that your original assumption is false. And this is an extremely powerful tool which we'll be making plenty of use of later on. But it also turns on our ability to introduce this upside down T, or this Folsom, and that requires another rule. This is the rule of Folsom introduction. Here's how it works. Suppose that we have in our proof P, and at some point we derive not P. These could be in any order. We could start out with not P and derive P. From these, we're entitled to infer this upside down T by Folsom, or upside down T introduction. And to justify this, we'll cite the lines down here on which the contradictions occur. So this rule is what we need to get this Folsom up here in our negation introduction proof. The Folsom is basically just a shorthand for P and not P, and there's one other application that it has that is really interesting from the perspective of indirect proof. This is the corresponding rule of Folsom elimination. If at any time we're running through a proof and we're able to derive the Folsom, then we're able to derive Q for any Q we like. This might seem a bit puzzling, but bear in mind that a valid argument is one in which the premises can't all be true without the conclusion also being true. And if the premises entail a contradiction, a Folsom, then there's something contradictory about them on some level, and accordingly they can't all be true, so they entail anything. If this strikes you as puzzling, I'd encourage you to pause the video and think a bit about how this relates to our definition of validity, wherein the premises can't all be true and the conclusion false, and if a set of premises in some way contains some contradiction in them, which deriving a Folsom allows us to show, then they entail anything. So if you'd like, try pausing the video now and just take a minute to think about this, or even go back and look at our definition of logical consequence to make sure that you have a firm grasp of how this works. So that's our rule of Folsom elimination, and we would just cite the line where the Folsom appears. So let's see how these rules work by giving a sample proof. Suppose our premises are P or Q and not P, and our goal sentence down here at the bottom is Q. Here's how we go about this. We would assume the opposite of what we want to prove in a subproof, which is not Q, with the goal of deriving a Folsom. Here we're going to make use of disjunction elimination, which we used in a prior video. I'm going to number these. Let's assume P, which is the first disjunct up here. We'll assume Q in just a minute. On line 5, we can get not P by just reiterating 2, which is to say reiterating our premise up here, not P. And that straightforwardly gets us the Folsom. Now if we assume the other disjunct, Q, this is the other disjunct of our premise 1, then we straightforwardly get Q, and reiterating line 3, oops, I should write in here, intro 4 and 5. Right, so assuming Q, we can reiterate line 3 to get not Q, because again, it's higher up, but it's in what you might call a superproof. We're in a sub-proof right now. And Q and not Q gets us the Folsom again. So lines 7 and 8 contradict each other. But notice that, again, moving from our disjunctive premise, P or Q, assuming P, we got a Folsom, assuming Q, we got a Folsom, which means that we're allowed to derive a Folsom down here by disjunction elimination, which we discussed in an earlier video. And this relies on 1 and the subproofs 4 to 6 and 7 to 9. Line 10. And from this, we're entitled to infer not Q. And, we're getting right down by the bottom. We'll rewrite our goal in here. By double negation, this just gets us Q. So we use the rule of negation elimination. And there you have it. So from P or Q and not P, we've assumed not Q, taken a detour through disjunction elimination by showing that if we assume P under the assumption that not Q, we get a Folsom. And if we assume Q under the assumption that not Q, we get a Folsom. And so we are allowed to take this disjunction, which appears in our list of premises above the main bar, derive this Folsom, and get the double negation we want on Q, eliminate that, and just derive Q. If this seems a bit involved to you, try running it through the Fitch program to make sure you understand how it works. Just to be clear, you have to click on the lines that you wish to cite, so make sure that you're using all your citations here and you're using the proper rules. So you can see now that in an interesting derivation, there's going to be a number of rules at play, and we've combined our indirect proof of Q by assuming not Q with a sub-proof within that assumption of P and a sub-proof within that assumption of not Q of Q. And by deriving these contradictions, we're able to get the negation we want and eliminate it to get the straightforward assertion that Q. So this is an example of a bit more of an involved proof because it involves Folsom introduction, disjunction elimination, negation introduction, and negation elimination. But it's a helpful exercise and it can be a lot of fun. I'll tell you, deriving this sign, the Folsom, is such a good feeling when you've been trying for it. It's really amazing. So I hope you'll take a minute with this proof, maybe write it out yourself, and make sure you understand what's going on here and how all the different lines and assumptions are related to each other.